Today's lesson is from Chapter 3, Lesson 4, Solving Equations Using Multiplication or Division. Your essential question, how can you use multiplication or division to solve equations? So what we're going to be looking at today is some inverse operations. We have a little key here that says, remember that multiplication and division are inverse operations. Inverse operations meaning that they undo each other. So the multiplication property of equality states that multiplying each side of an equation by the same number produces an equivalent equation. So algebraically, using letters, it says if A is equal to B, then A times C is equal to B times C. If you want to think of that in terms of numbers, if I said to you that 10 is equal to 10, that is a true statement. If I decide to multiply both sides by 2, 10 times 2 equals 10 times 2, do I still have a true statement? 10 times 2 is 20, and 10 times 2 on the other side is 20. I still have a true statement. So if I multiply by the same number on both sides, it still remains equal. Same thing goes for division. Dividing each side of an equation by the same number produces an equivalent equation. Algebraically, if A is equal to B, then A divided by C will equal B divided by C as long as C is not equal to 0. So for example, if I said to you 25 equals 25, that is a true statement. If I divide both sides by 5, 25 divided by 5, I end up with 5 is equal to 5. Still a true statement. Right? It keeps them equal. Dividing by the same number on both sides will keep an equation the same. So quick question, what operation is used to solve a multiplication equation? So if I want to undo multiplication, I'm going to use its inverse operation. What is the inverse of multiplication? Division. And what operation is used to solve a division equation? We're looking for the inverse of division, which would be multiplication. So if I have a division problem and I want to get the variable by itself, I'm going to use the inverse of division, which would be multiplication. Up here, if I have a multiplication equation and I want to get the variable by itself, I would undo that multiplication by division, or inverse operations. So let's take a look at some examples of that. We're going to solve an equation using inverse operations. Part A says x divided by 3 equals negative 6. So we need to undo the division. What's the inverse of division? Multiplication. I'm going to rewrite this over here so that I have a little bit more room. X divided by 3 equals negative 6. So in order to get rid of that divide by negative 3, I need to undo divide by negative 3 by using the inverse, which would be to multiply by 3. So when I write it like that, I can see that these are across from each other, therefore they cancel out. They become 1, leaving you with x by itself, because 1 times x is simply x. And what you do to one side of the equation, you must do to the other. That's what those properties up here were saying. If I multiply one side of the equation by 3, I need to multiply the other side of the equation by 3 as well to keep it equal. Negative 6 times 3 are integer rules. A negative times a positive is a negative, and 6 times 3 is 18. So my answer would be that x is equal to negative 18. So then I'm always going to plug it back in or substitute it back in to check. Negative 18 is my x. Divided by 3 equals negative 6. We want to make sure that that is true. A negative divided by a positive is a negative, and 18 divided by 3 is 6. So I end up with negative 6 equals negative 6, which means that that checks out. So what we did there was we solved a division problem by using the inverse operation, which is multiplication. What you do to one side of the equation, you must do to the other. Multiplication property of equality. In part B, we're going to look at the opposite now. This is now a multiplication problem. 18 equals negative 4 times y. How do I undo multiplication? What is the inverse of multiplication? That would be the division. Again, I'm going to rewrite it. 18 equals negative 4y. So if I'm doing negative 4 times y and I want to undo that multiplying by negative 4, I'm going to divide by negative 4. Negative 4 divided by negative 4 would give me a positive 1y, or simply y. We don't need to write that 1. Since I divided by negative 4 on that side, I'm going to come over here and do the same thing, divide by negative 4. Positive 18 divided by negative 4 is going to give me a negative answer, and 18 divided by 4 is 4.5, or 4 5/10 if we want to write it as a decimal. All right, we got y alone. We're going to substitute that negative 4 5/10 back into the equation to check our answer. Is 18 equal to negative 4 times negative 4 5/10? Well, I know that my integer rules say that a negative times a negative is a positive, so I know my answer is going to be positive. And 4 times 4.5 actually is 18. Therefore, it checks out and it is correct. All right, so when you see a multiplication problem, which you did here, remember when you have a number next to a variable with no sign in between, that states that it's multiplication. It's the only invisible operation. To undo multiplication, we do the inverse operation, which is division. So we divided both sides by negative 4 to get y alone. See if you can try these on your own. Pause the video and come back and check your answers. Remember, you are doing inverse operations, so if you see a division problem, you should be multiplying on both sides. And if you see a multiplication problem, you should be dividing on both sides to get the variable alone. Just as a quick reminder, in number 2, since you have negative a, think about what number is in front of that a. The only invisible number in front of a variable would be 1. So this says negative 1 times a, and you're going to get rid of that negative 1. So go ahead and do those 3 problems, then come back and check. In the first problem, you are trying to get x alone. The original problem says x divided by 5, so I know my inverse of division is to multiply by 5 on both sides. Multiply by 5 here. These are the same numbers diagonal to each other, so according to the multiplication, we can divide 5 divided by 5. They cancel out to become 1s. That leaves me with x by itself there. What I do to one side of the equation, I'm going to do to the other, and I always draw that line just to show you the difference between one side and the other side. So I multiplied by 5 over here. I'm going to come over here and do the same thing and multiply by 5. Negative 2 times positive 5 would give me a negative 10. I'm then going to check my answer by substituting it back in. Negative 10 divided by 5 equals negative 2. Is that true? A negative divided by a positive is a negative. 10 divided by 5 is 2. We end up with a true statement, so it is correct. In number 2, we're trying to get rid of negative 1 times a. The opposite of multiplication would be division here. I'm trying to get rid of a negative 1, therefore I'm going to divide by negative 1. Negative 1 divided by negative 1 would give me a positive a. What I do to one side, I must do to the other. Negative 24 divided by a negative 1. A negative divided by a negative is a positive. 24 divided by 1 would give me 24. And then I'm going to substitute that back in to check. So we're looking at negative, we're substituting 24 in for a, equals negative 24. There's actually no work to be done there. We can just see that that is a true statement. And in the last one, we've got 3 equals negative 1 5/10 times n. To undo that multiplication, we're going to divide both sides by negative 1 5/10. Negative 1 5/10 divided by negative 1 5/10 would give me a positive 1n, or simply n. What I do to one side, I must do to the other. We're going to do 3 divided by a negative 1 5/10. A positive divided by a negative is going to give me a negative answer. And when we do 3 divided by 1.5, we end up with a negative 2. We can then substitute that value back in. 3 equals negative 1 5/10 times negative 2. Remember that a negative times a negative is a positive. 1.5 times 2 would be a positive 3. That one checks out. Please remember that after you solve using your inverse operations, you should always be substituting in to check. Notice it does say, even in the directions, check your solution. It's how we find our mistakes if we made any. In example 2, we're going to solve an equation using a reciprocal. So just to remind you, what's a reciprocal? Remember, when we're talking about fractions, when you have a reciprocal of a fraction, you flip that fraction. So a reciprocal is when you flip the numerator and denominator. Of a fraction. So let's do some examples there. If I had the fraction 1/2, its reciprocal, we would flip them, would be 2 over 1. If I had the fraction 3/8, its reciprocal, I would flip it, would be 8 over 3. If I have the whole number 5, its reciprocal, I would have to think of how do I write 5 as a fraction. First off, all whole numbers can be written over 1 to make it a fraction. Therefore, its reciprocal would be 1/5. This should be review. And one more. What would be the reciprocal of 3 1/2? Now, here's a mixed number. So in order to find the reciprocal of a mixed number, we're going to have to change it to an improper fraction first. How do I do that? 2 times 3 is 6. 6 plus 1 is 7. So 7 over 2 is what we're really looking at. And the reciprocal of 7 over 2 would be 2 over 7. Right? That little review of what a reciprocal is. The next question says, how do you divide fractions? Well, you should be thinking to yourself, we don't divide fractions. We change it. There were 3 letters that we would think of. K, C, F. And what does that mean? Keep, change, and flip. Which means that you keep that first fraction, whatever it may be. You change from division to multiplication, and then you flip. So really what we're doing here is we are multiplying by a reciprocal. Right? That is how we actually divide fractions. Multiply by the reciprocal. And the way to help us to remember that, we say keep, change, flip. So let's take a look at this first example up here. We've got -4/5 x equals -8. I'm actually going to bring that, need some room down here. Oops. Move this down and rewrite that problem down here so we have enough room to work. So -4/5 x equals -8. So looking at this, you should be saying to yourself, okay, that's a multiplication problem. It's saying -4/5 times x. How do I undo multiplication? My inverse would be to divide. What am I going to divide by to get x alone? I'm going to divide by what's there with it, that -4/5. Any number divided by itself is always 1, so we can just cross that out. That gives me 1x, or just simply x. And I'm going to come over to the other side. If I divide it by -4/5 on the left, I need to do the same thing on the right. So -8 divided by -4/5 really looks like this. -8 divided by -4/5. When I apply my keep, change, flip, my -8 remains -8, but if I want it to look like a fraction, I'm going to rewrite it over 1. It's still -8. My change, my division, becomes multiplication, and my flip of -4/5 would make it -5/4. Remember, when you have a negative fraction, whether your numerator or your denominator is negative, the whole fraction is negative. It's one whole number. So now I'm looking at a negative fraction times another negative fraction. A negative times a negative should be a positive. If you want, you can cross cancel here because I can see that 4 and 8 have something in common. They are both divisible by 4. 8 divided by 4 would be 2, and 4 divided by 4 would be 1. Just have to remember that that's a negative up there. So I have a -2 times a -5, which would give me a positive 10. And 1 times 1 on the bottom would give me a 1, and 10 over 1 equals 10. So we have x is equal to 10 over here. Then what would I do final? I'm going to check my answer. So again, I'm going to push that down. Let's substitute it back in. -4/5 times positive 10. Does that equal -8? Well, a negative times a positive is definitely a negative. We know that for sure. I can actually cross cancel out here. Remember, this 10 is really just sitting on top of a 1. 5 and 10 both have 5. 5 divided by 5 is 1, and 10 divided by 5 is 2. So we're looking up at the top at negative 4 times 2, which would give me a negative 8. 1 times 1 on the bottom is 1, and then negative 8 over 1 is simply negative 8. Same answer on both sides of the equation means that we did it correct. So this keep, change, flip, this solving by using the reciprocal, all you're doing is changing these division problems into the KCF, multiplying by the reciprocal. But in hindsight, you really can just plug it right into your calculator, and your calculator is going to do that for you if you forget the steps of keep, change, flip. I want you to try it without a calculator first. I'm going to ask you to pause the video, work on 4, 5, and 6 using the keep, change, flip, and that's how I'm going to be doing them with you. And then come back and check your answers when you're done. So in number 4, negative 14 equals 2/3 x. We're looking at 2/3 times x. Undo multiplication by dividing. So I should be thinking on both sides of my equation, I want to do 2/3 divided by 2/3. Anything divided by itself cancels out to 1, leaving you with just x on that side. Since I divided by negative 2/3 on the right, positive 2/3 on the right, I'm going to do the same thing on the left as well. So we're looking at negative 14. I'm going to bring it down here to do the work. Negative 14 divided by 2/3. Negative 14 is my keep. I'm going to write it over 1 so that it's a fraction. Change from division to multiplication. The reciprocal of 2/3 would be 3/2. Looking diagonally, do I see anything that can be canceled? I see that 2 and 14 have 2 in common. They're both divisible by 2. 2 divided by 2 is 1. 14 divided by 2 would be 7. So we're looking at a negative 7 times a positive 3, which would give me a negative 21. 1 times 1 is 1. Negative 21 over 1 is simply just negative 21 for x. You should then always go back and substitute to check. So we have negative 14 equals 2/3 times negative 21. A negative and a positive here on the right side is definitely going to give me a negative, so that's a good sign so far. I'm looking at the 3 and the 21. Remember, 21 we can simply write over 1. They can cancel out because they're both divisible by 3. 3 divided by 3 is 1, and 21 divided by 3 is 7. So we're looking at 2 times a negative 7, which would give me a negative 14. And 1 times 1 on the bottom is just simply 1. Negative 14 over 1 is just negative 14. You can see that you have the same answer on both sides of the equation, proving that your work was correct. In number 5, you have negative 8 times b equals 5. Since we are multiplying by that negative 8/5, we're going to divide by negative 8/5 on both sides to get b alone. Negative 8/5 divided by negative 8/5 cancels out to a positive b, because a negative divided by negative is a positive. What I do to one side, I must do to the other, so I'm going to divide by negative 8/5 on this side as well to figure out what b is. So we have 5 divided by negative 8/5. My 5 as a fraction would be 5 over 1. That's my keep. My change from division to multiplication. And the reciprocal of negative 8/5 would be negative 5/8. Looking diagonally, I don't have anything to cancel out here, so I'm going to multiply straight across. 5 times negative 5 would be a negative 25. And 1 times 8 would be 8. I have an improper fraction there, so I'm going to divide. How many times can 8 go into 25? You're thinking 8, 16, 24. That's very close to 25, just below it, so it goes in 3 times, and that's a negative, because a negative divided by a positive is a negative. How many's left over? We got to 24, we need to get to 25, so there's 1 left over, and your denominator stays the same. So we have a final answer of negative 3 1/8. We're then going to substitute that one in to check. So I've got negative 8/5 times negative 3 1/8 should equal a positive 5. Well, a negative times a negative definitely is a positive, so we're looking good so far. I've got negative 8/5 times, I'm going to change that into an improper fraction so we can actually do the work. 8 times 3 is 24, plus 1 is 25. So we've got negative 25 over 8 here. I see lots of canceling that can occur. I've got 8 and 8, which when you have the same numbers diagonally, they always cancel out to 1 because they are divisible by themselves. And then 5 and 25 are both divisible by 5. 5 divided by 5 is 1, and 25 divided by 5 is 5. Now we can multiply across. We already said a negative times a negative is a positive, so we can go right to our numbers. 1 times 5 is 5, and 1 times 1 here is 1. I've got 5 over 1 equals 5, or simply 5 equals 5, so it checks out and it is correct. And then in the last one, you've got 3/8 times h equals negative 9. We're multiplying by 3/8, so to undo that, using an inverse operation, we're going to divide both sides by 3/8. 3/8 divided by 3/8, anything divided by itself is 1. 1h can simply be written as h. What I do to one side, I must do to the other, so I've got negative 9 divided by 3/8 on the other side. I'll come down here and do that. Negative 9 divided by 3/8. Keep my negative 9, just write it as a fraction. Change from division to multiplication, and flip 3/8, its reciprocal would be 8 over 3. Then look diagonally to see if I can cancel. 3 and 9 are both divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. We're now looking at a negative 3 times 8, which would give me a negative 24. And 1 times 1 is simply 1. Final answer just being negative 24. So we have h equals negative 24. I'm then going to substitute that one back in and check it. My original problem said 3/8 times h, and we know that h is now a negative 24, so I'm going to substitute that in, equals a negative 9. 3/8 times, I'm going to write this one as a fraction by putting it over 1. We want to see if that gives me negative 9 is my answer. I'm going to look across to see if anything can be canceled. 8, 16, 24, 8 and 24 are divisible. 1 time and 3 times. 3 times a negative 3, remember we have a positive times a negative, is a negative 9. 1 times 1 is 1. Negative 9 over 1 simply is negative 9. So they definitely check out and are equal to each other. Alright, so when we have multiplication problems, we know that we solve by dividing on both sides. And when you end up dividing by a fraction, you are really multiplying by the reciprocal. We're applying that keep, change, flip. Moving on to example 3. We have a little word problem here, real life application. The record low temperature in Arizona is 1 6/10 times the record low temperature in Rhode Island. What is the record low temperature in Rhode Island? So putting that into words, it says the record low in Arizona is 1 6/10 times the record low in Rhode Island. So we need some more information here, and we're going to get that over here. This gives us the actual record low temperature in Arizona. And if you can't see, I know they're hard to read, it's actually pointing to negative 40. Oh, it tells you that right there. So the record low in Arizona, I'm going to substitute that right into here, that negative 40, is, in math, is a keyword for equals. So we have negative 40 equals, and we have 1 6/10 times, that would be the keyword for multiplication, the record low in Rhode Island. Well, the question was, what is the record low temperature in Rhode Island? So that's my unknown. So we're going to call that T, since we're talking about temperature. You can use any variable, it doesn't matter. So I've got a multiplication problem here that I need to solve for T. How do I undo multiplication? I should be dividing on both sides of the equation. What am I going to divide by? I'm going to divide by what's attached to the variable, which we can see here is 1 6/10. 1 6/10 divided by 1 6/10, anything divided by itself is equal to 1, so that cancels out because 1 times t is simply t, so we just got t alone by doing that. What I do to one side of the equation, I always replicate on the other side as well. So we're looking at negative 40 divided by 1 6/10. A negative divided by a positive will always give me a negative answer. And 40 divided by 1 6/10 is actually 25. So the record low temperature in Rhode Island would be negative 25 degrees Fahrenheit. And we can go back and substitute that in to check. Is negative 40 equal to 1 6/10 times negative 25? Well, according to my integer rules, a positive times a negative is always a negative, and 1 6/10 times 25 is 40, so yes, that does check out. I want you to see if you can read the on your own problem to yourself. See if you can set up an equation like we did up here, and then solve for your equation to find the record low temperature in Alaska. Please pause the video now, read that, solve it, and then come back and check your answer. So on the on your own problem, the record low temperature in Hawaii is negative 1500 times the record low temperature in Alaska. The record low temperature in Hawaii is 12 degrees Fahrenheit. What is the record low temperature in Alaska? So it says the record low temperature in Hawaii. What am I going to plug in there? Well, they told me that that temperature is 12. So we have 12 degrees is negative 1500 times the record low in Alaska, which we don't know. So your equation should be 12 equals, for the is, negative 1500 times means to multiply your unknown. Again, we'll call it T since we're talking about temperature. How would I get my T alone? You should be dividing both sides by negative 1500. Negative 1500 divided by negative 1500 is 1. 1 times T is simply T. Draw my line. What I do to one side of the equation, I must do to the other. So we need to divide by negative 1500 on this side as well. A positive divided by a negative is a negative. 12 divided by 1500 would give you 80. So the record low temperature in Alaska is 80 degrees negative 80 degrees Fahrenheit. Pretty cold. Right? And then, like always, we're going to go back and substitute in to check. Is 12 equal to negative 1500 times negative 80? Remember, your integer rules state that a negative times a negative is a positive. And negative 1500 times negative 80 does give me a positive 12. Same thing on both sides of the equation, therefore our answer is correct. Right, so hopefully we were able to answer that essential question. How can you use multiplication or division to solve equations? Well, we use them by using their inverse operations to get these variables by themselves. That's the whole point here. When you're solving an equation, you're solving for that variable. You want that variable to be alone.